Terraforming, it sounds like science fiction. But it's a real concept, reshaping planets to be more like Earth. Imagine transforming a barren world into a life-sustaining environment. Terraforming involves engineering atmospheres, temperatures, and ecologies. It's about gradual changes over generations. It requires planetary science, large-scale engineering, and a vision for humanity's future. It's a testament to our desire to explore and find new homes in the cosmos. The ethical implications are debated, but the audacity of terraforming captures the imagination. It speaks to our drive to explore and innovate. As we venture further, terraforming may become a reality for future generations. When it comes to potential candidates for terraforming, Mars stands out. Sure, it's a cold, arid desert planet now, but beneath that rusty surface lies potential. Why Mars? First off, it's relatively close to Earth, making travel and communication more manageable than more distant destinations. This proximity simplifies mission planning and reduces the time and resources required for travel. Mars also has a day-night cycle similar to Earth's, lasting just over 24 hours, a familiar rhythm for future Martian inhabitants. This similarity would ease the transition for humans and other terrestrial life forms, minimizing disruptions to biological clocks and circadian rhythms. Most importantly, evidence suggests that Mars once had a thicker atmosphere and flowing water, crucial ingredients for life as we know it. The presence of polar ice caps, composed largely of water ice, hints at a more hospitable past. These remnants of a potentially life-supporting environment make Mars a prime candidate for terraforming, offering a tantalizing glimpse of what might be possible. Terraforming Mars is a monumental undertaking, fraught with challenges that push the limits of our current technology and understanding. One of the most significant hurdles is the red planet's thin atmosphere, which is about 100 times thinner than Earth's and composed mainly of carbon dioxide. This thin atmosphere provides little protection from harmful solar radiation, making it impossible for humans to survive without specialized suits or habitats. Then there's the temperature problem. Mars is bitterly cold, with an average surface temperature of about -63 degrees Celsius. This frigid environment makes it impossible for liquid water to exist on the surface for extended periods, further complicating efforts to establish a sustainable human presence. Water scarcity is another major concern. While Mars has polar ice caps and evidence suggests the presence of subsurface water ice, accessing and utilizing these resources on a planetary scale presents a significant engineering challenge. Extracting, purifying, and distributing water across a planet with limited infrastructure would be a complex and resource-intensive endeavor. Section 4. Engineering a Habitable World. Proposed terraforming methods. Despite the challenges, scientists and engineers have proposed several ambitious methods for terraforming Mars. One such idea involves using giant mirrors strategically placed in space to reflect more sunlight onto the Martian surface, thereby raising temperatures and potentially melting the polar ice caps. This increased solar radiation could trigger a cascade of effects, including the release of trapped greenhouse gases, further warming the planet. Another proposal focuses on releasing greenhouse gases, such as carbon dioxide and methane, into the Martian atmosphere. These gases could trap heat, leading to a gradual warming effect. Potential sources of these gases include the Martian polar ice caps and soil. Releasing these trapped gases could potentially thicken the atmosphere and trigger a runaway greenhouse effect, making the planet warmer and more hospitable. These are just a couple of the many ideas being explored, each with its own set of advantages, drawbacks, and uncertainties. The key takeaway is that terraforming Mars would require a multifaceted approach, combining different methods and technologies to achieve the desired outcome. Section 5. A future under Martian skies. Colonization and beyond. The dream of terraforming Mars is linked to establishing a permanent human presence on the red planet. SpaceX, NASA, and private companies have ambitious plans for Mars exploration and colonization. SpaceX envisions a self-sustaining city on Mars aiming to make humanity a multi-planetary species. Their Starship program is crucial for Mars colonization. NASA's Artemis program paves the way for a future human mission to Mars. Predicting a timeline for Mars colonization is challenging. Estimates vary, with some suggesting humans could land on Mars within the next decade. Terraforming Mars would likely take centuries to achieve significant results. Despite the long road ahead, the pursuit of terraforming Mars continues to inspire innovation. pushing the boundaries of science and technology, and igniting our imagination about life beyond Earth.